Good afternoon. Let me introduce the program. This is the third workshop on spatial data analysis and mapping with Supermap Software Corporation Limited, China, in collaboration with the Faculty of Geomatics, Sabaragama University of Sri Lanka. This forum is not only for the local students, but it is open for the international students as well. As we all know, Sabaragama University of Sri Lanka is the only state university in South Asia which offers BSc in Survey and Sciences. Today, the third workshop will address the areas of spatial analysis for vector data and spatial analysis for raster data. As usual, our resource persons for the workshop are Mr. Jason and Ms. Chin Zhang. Ms. Jason is the technical manager of Supermap International and Ms. Shin is the technical support engineer of Supermap International. Dear sir, madam, it's over to you to continue the workshop. Dear participants, now you all can join with the lecture on spatial analysis for vector data.
Hello everyone, this is Qin speaking. Can you hear me?
Yes.
Okay, now let me share my screen first. Good day, guys. This is Qin. I'm a technical support engineer in Asia and Oceania Center. In the following two courses, I will be your instructor, and my topic is mainly about the GIS spatial analysis. So all of you know that the spatial analysis is the core application and is the core technology of GIS. So in these two courses, I will introduce you what is spatial analysis and what we can do with spatial analysis. So now let's begin our first course of spatial analysis. Our course is also based on the Supermap at desktop, and then our content includes three parts. The first part is spatial analysis, which is the topic we are going to talk about today. And in the last course, the section 2 and section 3, I will introduce these two contents in the last course. It includes network analysis, spatial statistic analysis, and the 3D modeling, and also 3D spatial analysis. So today we are going to mainly talk about the spatial analysis. And our course is divided into two parts. The first part, I will firstly introduce you the basic concept and operation of our content, and the second part, I will demonstrate you how to make application with the content, also how to achieve the application with spatial analysis, and also the statistic analysis, also 3D modeling. So let's go to the first part, spatial analysis. Let me first introduce the spatial analysis, and here, let me get this one. So the spatial analysis includes three parts. Firstly, I'd like to introduce you the query in SuperMap. Since the query is the basic operation for the spatial data, so I want to know. I want to firstly know how to query in the SuperMap at desktop, since it will be used in many processing steps. So firstly, I will introduce the queries, and then I will introduce the vector analysis and the raster analysis. So let's first take a look at the queries in SuperMap. There are three queries in SuperMap: the simple query, spatial query, the circle query. Let's take a look at each query. So the simple query is to browse associative tables, attribute tables with the spatial data. So you can easily know the just like if you open a map, you can click one feature, and then you can view the attribute table of the related with the feature. So we can just like this picture shows that if we click to one feature in the map, and then we can find out the attributes in the attributes table of the feature. So you can do. You can also click. You can also click the one feature in the attribute table, and then the features in the map can be highlighted in the map. So this is about the simple query. This method often used to check the attributes of the feature and you want to know. So, and the next is about the simple query. The simple query is to set here also is a simple query. The simple query also can check the more information of one feature, just like the properties and the spatial information and the nodes information. So also we can find the information by simple query. And the next is about the spatial query. We know that the data in the spatial also we can understand all the data in the real world has spatial features. So we can when we can use this spatial query. Here I list some examples. The first one here we can see that if you want to find out which countries are located on the equator. Maybe if you're familiar with some countries, you can know which countries are located on the equator. But if you don't know more about one country, and also you want to know all the countries which are located on the equator. So here we can use spatial query. We can just we can firstly open an equator layer, and then we can add the country data to the same layer. So here we can adjust the relationship between the countries and the equator. So it's easy to know that only the countries intersect with the equator. So we can see that the countries are located on the equator. So here are some conditions of spatial query. The across, contain, within, overlap, disjoint, touch, identity, and intersect. So we can adjust the spatial relationship between these conditions. And so here is the case that to find out the countries located at the equator. So firstly, here we can see that we end the two layers. One is the grid layer, and another layer is the country layer. So here we can judge the equators relationship with the countries. So here we can set the maybe the cross line region or intersect line. So here we can find out all countries located at the equator and output the results. So this is a simple case for the spatial analysis application. And then I'd like to talk about the circle query. The circle query is to construct a circle expression to query spatial and non-spatial data. The spatial query is to use the this situation only if we know the spatial relationship between two features. But if we don't know the spatial features, or the data don't have this spatial spatial relationship, here we can use the circle query. Here is an example to query the countries which population is more than 100 million and store the query results in a new data set. So here we can firstly locate at the data we want to query, and here we set the circle expression like this, or the world population is bigger than 100 million, and then we can output the results. Also, the result also can be highlighted on the map, and also the attributes can be output. So the next, I'd like to talk about the vector analysis. The vector analysis includes buffer analysis, overlay analysis, and proximity analysis. Let me first introduce the buffer analysis. The buffer analysis is to you can understand to extend area of one point or lines or regions. So here just let's see, we can see this. If you have point data, we can do buffer analysis to check which areas affected by this point, such as the meteorological stations or the pollution stations. We can know we can know the effect areas, and also we can do the line buffer. So just like if you want to if you have planned to expand a road, and then maybe you you don't know what wise the road should be expanded since there are buildings by the side at the side of the road. So here we can use the buffer analysis to check to find out which buildings will be affected by the road expanding. And also we can do the region buffer. So here all this so just we can use it to get affected region around some dangerous spots or so this buffer analysis is widely used in GIS spatial analysis. Then here is a case to find buildings that will need to be demolished due to the expansion of our road. So, so firstly, we can create a buffer and set the radius of the buffer. So we can here the radius is 8, and after we get the buffer results, and then we can further use this spatial analysis to adjust the relationship between the expanded roads and the buildings relationship. So here we can find out the affected buildings by the expansion, by the road expansion. So here we can make decisions to if we need to expand this width, or we can reduce the width of the road, the road expansion. And furthermore, we can also create multi-buffer room, just like we can create a multi-buffer room for a railway line to analyze different levels of noise affection to the residential areas nearby. So we can set different radius and to get the analysis results. And the next, I'd like to talk about the overlay analysis. The overlay analysis is the operation of comparing variables between two data sets. So here are some application examples. First, find out the lake distribution of a certain province. So here we can overlay the lake layer and the administrative layer to get out the lake distribution. And also the second one is with the land use data in 2 years, we can get the land use changed areas in these 2 years using semi-tracks. And the third application is with land use data and recovery for the distribution data. We can get the new land use data after recovering use update. A simple application is to analyze the change of land use. So here we can input 2 different years land use data, and then with the overlay analysis, we can get the changed land use results. Here are some modes of overlay analysis, including clip, erase, intersect, union, identity, XOR, and update. Each each method based on your reality applications. Just like here, we are going to get the land use data of Liuzhuang village. So just like here is one city's data, we just want to get the data of Liuzhuang. So here we can use the clip overlay analysis to get the data of Liuzhuang village. Here we can input the boundary of Liuzhuang and then overlay with the land use data. So here we can just get the result of the Liuzhuang village. And the third one is about the proximity analysis. Here are two methods. The first one is Tyson polygon, and the second one is measure distance. So the Tyson polygon is created by denoting triangle net, and then finally construct Tyson polygon. We know that the Tyson or the descript point in Tyson polygon, how to say, one we know that one Tyson polygon includes one descript point, and the points in the in one just like 0 point in one Tyson polygons, and the closest point is the related is the associated descript point. So if we want to know which is the where is the closest hospital in one area, and you may just like you are in school and you want to know where is the where is the closest hospital. So here you can use the school use the school point to create the Tyson polygon, and then you can add the hospital points into the map, and then you can find out if the hospitals are in your school area, which is the Tyson polygon. So so this one is the closest hospital to your school. And the next one is measure distance. The measure distance can get the closest distance from two group of points. So here let's take examples directly. Then like the first case is about the national precipitation map. This application creates Tyson polygons for meteorological stations in China, and then creates a range schematic map to show the ranges of average precipitation for each polygon area. And this case is to find out the nearest hospitals to the schools. So this application is based on the measure distance. So here we can find out the with the two groups of school data and the hospital data, we can find out the nearest hospitals for each school. So here is just like this school, Xinmin elementary school, the nearest hospital is the second part of hospital of Jini University. And here shows the distance from the school to the hospital. And for the other, the number 19 schools nearest hospital is also the second part of hospital of Jini University. And the distance is shown like this. So here is the application of proximity analysis. And then we are going to talk about raster analysis. The raster analysis based on the raster dataset, where we divide the spatial analysis into vector analysis and raster analysis is because the vector analysis based on the vector data and the raster analysis based on raster data set. So here some contents I'd like to introduce to you. The first is the raster data types, and then I'd like to introduce you the interpolation, and finally I will simply introduce you the surface analysis of raster data sets. So here, let's take a look at the raster data structure. And as I said that the vector data is displayed like the middle level, and the raster data how to express the real world by raster data. The raster data express the world by the pixels. Here we can see 1 point is 1 pixel, and a line is combined with a series of pixels. Also, the regions is also composed by a series of points. So this is the raster data. And here there are 3 types of raster data. The first one is the DEM model, which also the DEM model is also the grid data, which depicts just the pixel values represent the elevation information, but other grid data pixel values represent other business information such as the precipitation, temperature, and other values. And the third data is the image data, just like the remote sensing images, satellite image, or other photos. And the different data sets displayed different in the supermap at the top. Just like the grid data, the icon shows like grid, and if the data is image data set, and the icon is displayed like a picture. And then I'd like to talk about interpolation. The interpolation is to get a raster data set based on a point data set. Just like if you have a group of meteorological stations data, so here you can use the interpolation to get the temperature distribution or other meteorological elements distribution results by interpolation. And in the supermap also provide IDW creaking and spline methods to achieve interpolation. Here is a case to show how to get temperature distribution map from interpolation. And here we first prepare the national meteorological station data and then do the interpolation analysis. So finally, we can get the here we set the field at temperature or set the field as precipitation or wind or other meteorological elements, and then we can get the distribution results. Furthermore, we can also extract the Isolines and Isoregions of the interpolation results. So then the next is about the surface analysis of raster dataset, just like the slope to get the slope of DEM data, and after we get the slope analysis results, we can reclassify results and to get a different level of slope for your further application or analysis. Just like it also used in the water and soil loss research. So the slope element is very important. And the next is the aspect analysis. So we can get we can know the slope direction. And the Ortho Image. The Ortho Image is to create an image looks like 3D data. And also we can firstly get the Hillshade of DEM and then overlay with the DEM data, and then set the transparency of these two layers to get the overlay map, which has the same effect of the Ortho Image. So that's all the basic concepts of this course, and the next part we are going to demonstrate how to use the spatial analysis to do the reality application. So let's take a look at this second part. Here, let's go to this first section, spatial analysis. Before we are going to do the spatial analysis, we should download the data. Here, I also here I list some links to download the public data. Firstly, the DIV GIS. I think Jason already introduced to you to download the administrative data. This is the data type of DIVA provides. And the result of the download data are zip files. And then in the spatial analysis, I want you to download the OSM data. You can download the OSM data via the public service. And also, I want you to download the data of you in your country or the country you are interested in. So And also for the spatial analysis, we are going to make a precipitation distribution map. So I also need you to download the meteorological data through the NOAA. And here is the link of the download link of the here is it download link, and also you can select your country's data to download, and you don't worry about how to download this data from this website, since I also prepared the materials for you to how to download data from the NOAA and the manual introductions about how to download the data, how to prepare your data for the spatial analysis. So you don't need to worry about that. And after you download the data, we should import the data. This is the same way that introduced by Jason. So you should first new data source and the important the different types of data to the data source. So after we import the data, it will be like this in the Superman desktop. And after the preparation work, we are going to do the spatial analysis. So our topic is to analysis of national meteorological elements. And so this section mainly uses the spatial analysis method to realize the analysis of the national meteorological elements. In this course, we need meteorological data which downloaded from the NOAA, and the administrative error data and the DEM data downloaded from the DIVA. Here, let's take a look at the workflow of the work. Firstly, we need to import the data, and then we should further process the data, and then do the spatial analysis to get the meteorological elements distribution results. And the next work is to lay out the results. And finally, we need to further analyze the result you make. Just like here, we should convert the text to point, since the meteorological data downloaded from the NOAA a text with text format. So we need to convert it to point, and then we can do the process. Test and polygon analysis, and also the interpolation to get the meteorological element distribution result. So and what's more, we can export the analysis result by layout. As this part is the contents you learn from, I think you learn from this second course about the layout, which also is the important. So it can make your map much more beautiful or meaningful. And what's more, we can also make the time series precipitation results. So here we can note the change of each day or each week or each month or every years. And also we can analyze the temperature distribution results and also make the time series results to analyze the change of temperature in your country. So here just like the October 1st, October 2nd, and October 3rd. These 3 days, you can do more, or you can do the weekly change, or the monthly change, or yearly change map. And after the results finished, we should analyze the results. Just like you can describe the results of the analysis, you can analyze not only precipitation but also temperature, visibility, or other elements. And also you can analyze of the relationship between meteorological elements and topography. And also you can make a group of time series meteorological elements changing maps to analyze the change of a certain period. And this is about the basic contents. And then I think we can take 10 minutes break, and then we are going to the desktop to go to our hands-on parts. So how about we take a 5 minutes, I think 5 minutes break, and let's back and yeah, I think let's take a break first, and we will start in 5 minutes. Okay, welcome back. Let's continue our training. So this part is the hands-on part. I'd like to demonstrate you how to make spatial analysis and how to make precipitation distribution results. So firstly, as I said, that we should download the data. Here this data downloaded from the DIVA, and this data downloaded from the OSM, and this data, the daily meteorological station data is downloaded from the NOAA. So firstly, we can import the administrative data, and I think the administrative data and the meteorological data and DEM. So let's take a look at how to import it. Firstly, here I also have already created a data source named spatial data, and then let me import the administrative data, original data. I downloaded Thailand as an example, so you can download the country of your own, the data of your own country. Let me import the shape data. Here we can import and up the shape file and import it. And here we also need to import the terrain data. Here we select grid to import the DEM data. Here we should pay attention to is that the import mode, we should yeah, no, sorry, I made a mistake. There's nothing here. We just need to keep it all as default and then import it. Oh, sorry. No. Here we should import the VRT format. I just select the wrong format, and then here, here we should pay attention to it that to change the type, change the image to raster. And I just mentioned that there are two types in Supermap, raster data and the image data. And the DM data, it belongs to the raster data. So here we need to change the type to the raster data, and then import DM data. And then we're going to import the meteorological station data. Here I downloaded the daily data of October. So here maybe, and here I'm going to import the data as point data. So here we can check the CSV data, the features, it includes the latitude and longitude. So here we can check the import spatial data, and the coordinates longitude we select the longitude, and the latitude we select the set it as latitude. And if you want to import it as 3D data, also you can set the altitude as the elevation. Here we just import it as 2D data, and then we import it. So here we can add this data. Here we just only add this these two labels, administrative data, to a new map. Let me take a look at the administration 0 is the country boundary, and the administrative 1 is the province level. And here we can check the DM data, also add to the current map. Here is the terrain of Thailand. And here we add the meteorological station data to the current map. So here we can see the distribution of the meteorological stations. And here then we can check the attributes of each data. Here we can hide the system fields. Only we can see the name 1 is the country name Thailand, the name 0 is the country name, and the name 1 is the province name. And here we can also open the to cross attribute table. Here we can check the meteorological station data. Here we can see the station ID, the station name, and the elevation, and the date. Here it includes all October's recordings for each here recorded by each station from the October 1st to October 31. And here we can check the fields of this meteorological data. And here we can see the PRCP represents the precipitation value, and the SNDP represents the snow deep. And here I think this one is no use. And also here we can check the temperature data, user temperature. And and the visibility, the wind speed, and others. So here, the first step, I'd like to analyze 1 day's precipitation distribution. So the first we are going to do is to extract the meteorological data of 1 day. Here I just suppose I'm going to analysis the first day of October. So here we are going to extract the data of this day. How to extract the data? Here we are going to use the method I introduced just now. We are going to use the SQL Query. Since we only know the condition of the query, so here we can going to use the SQL Query. Here we are going to find the SQL Query based under the spatial analysis. So here we can check under the spatial analysis, we can find the query, SQL Query, spatial query here, and also we can find the vector analysis, buffer, overlay analysis, proximity analysis, which are all I introduced just now, and the raster analysis include the surface analysis, the slope analysis, aspect analysis, Hillshade analysis, and the interpretation, and the other raster analysis is under this menu. So here we are going to use the SQL Query to find out the data in October 1st. So here we can just first select the dataset we are going to query, and then we select, here we can just select if you want to select all the fields, you can just click here. This one, it means the all the fields will be stored in the new in the query results. Or here you can also select the data you only want to you only want to analysis, just like the station name, or the precipitation, maybe the temperature, temperature users. User temperature, and here where we should set the condition that we are going to select the user date. Here is user date equal. Here we can get the equal value. We can select the October 1 or any day, any days you want to analysis. Here I set it as October 1st, and then here I save the results as station October 1st. So here is a new data set generated, and here we can plot the attribute. Here only shows the fields we selected, and then the next we are going to what we are going to do is to here let me remove the previous data, and I think we can and the data to the current map. And then what we are going to do is to to get the meteorological element error. So here we are going to use the proximity analysis. We are going to create Tyson polygon. Here we are going to find the spatial analysis, proximity analysis, Tyson polygon, and here we select the station October 1, and here we can capture the locale. We can select the country's boundary, and then the data set we can see that as October 1st. And here we can display map. The processing takes time, so here we just be patient and wait it until it finishes. So here we can get the result of the Tyson polygon analysis.
Excuse me?
Here we can see that every Tyson polygon includes one discrete data. That means here we can easily know that these errors these errors are affected by this station. And what more we can do is to create a semantic map. We can create a ranges map. So we can even need to know the range of the precipitation. Here, just like we want to know the ranges of the precipitation. Here we are going to set the expression as precipitation, but here we can see there is no precipitation result. And here we can check the attribute table. Here we can find out that the precipitation and the temperatures type a white character which are not supported by the semantic mapping. The expression should be numerical. So here we can change it as numerical and double and apply it. And then let's check the result. It is double. And then let me remove this one. I think we can modify the semantic map, and I think we need to create the semantic map again. This map. Here we change it. It's not updated in the layer manager. So here we just delete it and add the to the time map again. create semantic map. Here we can see the expression can be set as PRCP or temperature. And what's more, we can do it to change the color scheme or the range counts. Or here we can check the results, the precipitation situation of this day. So here we can So here we can, most areas are not raining in that day. And so here we can see the, and then we can divide it, we count at 10. And here we can change it at 0. 1, 5, 10. Just like this. So here we can know which areas is raining and which areas are not raining in that day. So here we can see these 5 areas are raining most that day. And so what we can do more is to export the results and to label the raining areas, just like this picture says here. We can use a highlight icons to and make the labels of the areas which of the stations which raining most. And so the next work is about the layout. I will not show the steps in our course, but you can refer to the document I shared with you. Select the spatial analysis. So about the layout part, about how to make your analysis results much more meaningful. And then the next, I'd like to show you how to get the precipitation distribution map by interpolation. Firstly, we also need to change the. We also need to change the precipitation or temperature fields as numerical data. Actually, this step should be firstly processed operated. So we can just use this result to do other operation. Check the result. Double. And then here we can make this layer and the and it to the current map again. And then here we are going to find the interpolation. And here we are going to use the simple querying to do the interpolation analysis. And the field we can see it as PRCP. And if you want to analyze the temperature, you just change it to temperature. And the interpolation and the data range, we can select the country's boundary and right click to end. And then next, finish it. Here we can see there is a new grid dataset generated and current map. So here we get the result of the interpolation. And the next we are going to do is to clip the results. We only keep the results in our country. And here we are going to find the yeah. And here we can go into find maps and map clip, select object area clip. We select the country's boundary and right click it. Here we just keep the interpolation result in the box and the interpolation time and okay. We can add the new grid dataset to current map. Yeah. So here we get the result of Thailand area. And what we can do, here we can check the result of the interpolation. Here is the precipitation values range of this map, but there are too many values, so we don't. We may either need to know this area it was raining, and this area also these 5 areas were raining in that day, but we don't know the actually values of this area. So here we can also use the reclassify method to reclassify the result. Here we are going to also create semantic map of the grid results and the grid ranges data. Okay. And here we can see there also we can set the range count. And here we can see the color scheme. We can change it to this more like raining, and here we can change the ranges value. Yes. So here we can see these areas were not raining that day, and these areas were raining most in that day, and we can see the result as integrated value. Okay. So it will be useful for your final result, final layouts. So here we get the result like this, and also we can do the further layouts work to label the training stations like this. Here we can also here we can and And the next, I'd like to show you some surface analysis with the DM data. Current map. So here we can do the surface analysis. We can extract Isolines, and also we can create Hillshade. And here, to current map. And here we can change the color schemes of the Hillshade by right-click at the layer properties and the setting color table. And here we can change to the Hillshade. And okay. And here we can change the order of the layers. Here we can set the transparency of the DM data. 30. So here we can see there gets the 3D effect. And what we can do more is to overlay with the analysis results. Here we can also set the transparency of the classified results. What more we can we can set the layer of the province. And so here we can also label the province name, so we can know which province or which cities were raining in that day. And then after we do this work, we can further lay out the results. For the time limits, I don't have time to show all the steps. So here I already made the layouts the result. Select the precipitation map. Here is the Tyson polygon result, and I label make the label of the areas which mostly raining in that day, and the interpolation results. I also overlay it with the DM data, and then make labels of the areas which raining that day. And then I also make a layout. So here I make a layout of this result. So here we can see the station highlight, the stations highlights are the stations with precipitation more than 50. So here I mean there is a mistake of the unit of the precipitation actually is the inches. So here we should so here, and also I show the precipitation ranges, and the city, and so here and the legend and the title and the skills and the nodes array of the map, and here I should and then we can output the results as picture or PDF. And after that, we can do the analysis of the results, just like you can describe the results or analyze the precipitation reasons in this area or in that years. Also, the Python polygon also made results like this. So I hope you can also make a complete result by following the manual guidance. So I finished the demonstration. On the next, I'd like to give you a homework. So here is the requirements of the homework is to complete test and polygon and the interpolation result of at least one meteorological element. That means you should at least complete one meteorological element. Just you need to finish the precipitation analysis results or the temperature analysis results, and then make the analysis of your results. And I also assign the work in the Google Classroom. So you can check the work in the Google Classroom and download the materials from this link. And also, after you finish your homework, you can submit your work through the Google Classroom, or if you cannot log in Google Classroom, you can send it to my email. I think you have my email now, and also you can submit your I think you can submit your work through the what that's let me check. So I forgot. I think EVLE. You can also upload your work through EVLE. I think that's all for today's course. And in the last course, we are going to talk about the network analysis, statistic analysis, and 3D modeling. So thank you. And if you have any questions, you can also email to me. That's all for today. Thank you. Bye.
Thank you, madam, for sharing your precious knowledge with us. Dear participants, it is highly recommended to use the VLE system to upload the assignments, as it is a mandatory requirement in issuing the certificates. So see you all in the next session, which will be the last workshop of the forum. Thank you. Stay safe.